So here is first question, and there is common statement for question number 1 and question number 2, that an object is sliding on a track and it is released from the top and track is frictionless. Okay, so first question is, at which of the point the object will have maximum potential energy. So this question is based on concept of energy. As we know, the potential energy of any object depends on position of the object. And it can be termed as mgh, where m is the mass of the object, g is acceleration of gravitation, and h is height of the object. So in this figure we can see that at position A, object will have maximum height. So at this point potential energy will be high. So choice A is correct for question number 1. Now question number 2. At which point object will have maximum kinetic energy. So there is concept of conservation of mechanical energy, and mechanical energy is sum of potential energy and kinetic energy. So if system is isolated, the potential energy of system, mechanical energy of system remains conserved. So it's simple a process of exchange of potential energy in form of kinetic energy and kinetic energy in form of potential energy. So when object will move down, its potential energy will decrease and kinetic energy will increase. In this figure we can see at point B, the height of object is minimum, so potential energy will have minimum value. That's why kinetic energy will be maximum at point B. So choice B is correct for question number 2. So question 3 to 6, there is common statement that a person throws a ball with initial velocity v0 from the deck of a house. Okay, and for all the projections, the direction of projections are different and height of projection is same, that is h. So let's start with question number 3. In which case does the ball travels greatest horizontal distance before hitting the ground? So these questions basically based on two-dimensional motion, that is projectile motion. So in case of projectile motion, there is very important point that we need to deal with horizontal component of velocity and vertical component velocity separately. So in diagram we can see in figure A, the object is projected in horizontal direction, in B it is projected in vertical direction, in C it is projected directly downward, and in D it projected at certain angle. So in case B and C, there will be no horizontal displacement as the direction of ball is either in vertical direction or in downward direction. Okay, so there is no horizontal component, so there will be no displacement. Now when object is thrown from same height h and there is constant gravitational acceleration g, so from equation h equals to ut plus half gt square, where the vertical component of velocity is 0 or it is some less value, then the t will be same for hitting the ground. Okay. So the displacement from the bottom of this building will be horizontal component of velocity and time to hit the ground. So in figure A and D we can see the maximum amount of horizontal component of velocity in option A. So R will be maximum for V0 into T, which is in case of A. So choice A is correct for question number 3. So next question is, in which case does the ball have greatest speed when it hits the ground? So if we look at the initial position of each projection, then all the ball have equal height, so they will have same potential energy, that is equals to mgh. Each object have same speed, so they have equal kinetic energy, that is half mv0 square. And when the ball hit the ground, there will be same amount of loss in potential energy, so the kinetic energy of each object will be same. Okay, that's why the velocity of every object will be same. So choice E is correct for question number 4.